Welcome back to part 2 of Inferences about two population proportions. Remember that we were working on a problem where we're testing to see if the drug is effective at preventing heart attacks. And so we said group 1 was the experimental group, the group that gets the drug, and group 2 was the placebo group that as our control group. And we wrote down our known information. And we're trying to see if, remembering that a success is another heart attack, if the drug is effective at preventing heart attacks. And if we're preventing heart attacks, then we should have fewer heart attacks if the people get the drug than if they don't. So that tells me that my alternate hypothesis should be that the proportion of people, the population proportion in group 1, if we were to give it to everybody that would have another heart attack, is lower than the proportion in group 2, people who don't have the drug that have another heart attack. Therefore, our null hypothesis, I'll just go ahead and go equals. You could use greater than or equal to, but I'm just going to go ahead and use equals. And we said that we were going to use a 5% level of significance. Okay. And based on our alternate hypothesis, we notice that less than is to the left on a number line. So this is going to be a left-tailed test. So let's again look at our two different methods, the traditional method and the p-value method, and then kind of do a little bit of compare and contrast. You're welcome to use whichever one you like the best. So if we do our traditional method, we have a 5% level of significance on a left-tailed test. So we need to find the critical value that will give me 5% of the area in the left tail on the z distribution, because we're using the z distribution because he's a binomial and we have a large enough sample size, using the normal approximation to the binomial. So 5% was 0.05, and 0.05 would be right in between these guys. So the z-score I need is 1.645, but negative since he's on the left side. So our critical value is z sub c, c for critical, negative 1.645, and anything out here is going to be beyond reasonable doubt. Okay. So we'll write z sub c is negative 1.645. Now, we need to find out what the evidence says, and the test statistic is our number based on the sample evidence, but because of null hypothesis being P1 equals P2, this term goes to 0, so it really just works out to be this guy. And so let's see how we can compute him on our calculator. Fortunately, we still have, if I slide it back down, the important information up here. So let's turn that back on and see if we can avoid some glare. And so we'll do some parentheses. P1 hat is 0.90 minus P2 hat, which is 0.149 divided by the square root of, okay, now I'm going to have an operation here, so I'm going to put these guys in parentheses, these guys in parentheses, and then some big parentheses for the square root. So P bar times Q bar, so that would be 0.118 times 0.882 divided by N1, which was 100. Now that closes just the first piece, plus P bar times Q bar over N2, which would be 0.118 times 0.882 divided by N2, which was 87. We'll close that piece. Now let's close the square root, and, uh-oh, hang on. Aha, I found out my problem. I didn't hit the 0 hard enough here, so I'm going to do second enter and change this back up to be 0.090. Okay, all right, so my test statistic comes out to be negative 1.25 to 2 decimal places. Okay. And if we graph that on our picture here, negative 1.25, negative 1 1/4, This is our test statistic, so we don't put a C on him because he's not the critical value. But you'll notice that our test statistic landed outside of the critical region, so we will fail to reject H naught, meaning we do not have enough evidence to conclude that the drug is effective at preventing heart attacks. Okay, so finally got through that one. Let's go ahead and see if we can get some additional help from our calculator. So we're going to see if we can run a stats test. Now, since we're doing two sample stuff and we're dealing with a proportion, the correct program would be 2 proportion z test, because we're taking two samples and comparing head to head on a proportion. We're using the z distribution, and this is a hypothesis test, not a confidence interval, like we'll talk about a little bit later. So 2 prop z test, it asks us for x1, which was 9, n1, which was 100, x2, which was 13, and n2, which was 87. And what was our alternate hypothesis? Our alternate hypothesis was that, let's come back up here, P1 is less than P2. So we'll make this line look like our alternate hypothesis and calculate and write down our information here. Okay. So if we write this down, so we've got 2 prop z test. We find out that z equals negative 1.26 to 2 decimal places. The next thing is our p-value, which we'll use here in just a minute, and that was 0.1042. P1 hat, it reminds me, is 0.09. P2 hat, it tells me, is 0.149 to 3 decimal places. And just the p hat is 0.1176, which will round to 0.118, which is, according to our notation, we call that p bar. So how could we have solved the problem starting at step 3 using the help from the calculator? Well, we still need to find our critical value of negative 1.645, draw our picture, let me slide that up. Put on the critical value and make the critical region. Okay. Then we could use the calculator to find our test statistic for us, negative 1.26. Notice that that's very, very close to what we've found here. The only difference is a minor rounding error because the calculator kept more decimal places. But we would then plot our test statistic of negative 1.26 and note that he is outside the critical region, so we will fail to reject H naught, meaning we do not have enough evidence to conclude that the drug is effective at preventing heart attacks. Okay. All right, so that's how we could use the traditional method and the calculator together. Now remember that the p-value is the probability of getting that extreme of a result just by random chance. So what's the chance that we would get this extreme of result? Well, on this left-tailed test, it would be the area outside of the test statistic, in this case to the left of the test statistic of negative 1.26. And if we look at negative 1.26, the area to the left of that is 0.1038. So if I do the table, I find out that my p-value is 0.1038 because my test statistic was negative 1.26. And notice that that is to 3 decimal places the same thing as what the calculator gave us. The calculator was able to carry more decimal places, so it's slightly more accurate. But once again, we could take our p-value of, let me write this here in black, p-value of 0.1038 or 0.1042 if we use the calculator. And if we compare that against our alpha, alpha was our level of significance of 5%. We see that the p-value is greater than alpha. And if the p-value is greater than alpha, we remember that we fail to reject H0 because the p is not low, therefore the null doesn't go. Okay. All right, we'll pick up there in the next video.